we're back, and I'm at lesson 115, and we have a special guest helper here, teacher assistant. This is Jimmy,
Hello.
and Jimmy is Angie, my wife's cousin. And we're actually staying at Jimmy's family's house here in Tucson. So he's going to help out because he actually has already taken Algebra 2, and he's a whiz kid.
Not really. Okay.
Okay, so we're on lesson 115, and it's about exponential equations and also exponential functions and compound interest. So if we look at something as basic as saying that 10 squared is equal to 10 to the x, if the bases match, then the powers, basically we're setting these two equal, the powers are also matching. So in this case, and we can work this out by saying 10 squared is 100, and so 100 is equal to 10 to the x, so therefore x is equal to 2, which is basically saying that the two exponents match. So for exponential equations, we look at an example, and we say that 17 is equal to 10 to the x plus 2. We can't, the bases are not equal. We can't say that 17 to the 1, 10 to the x plus 2, this is not going to help us at all. We need to get this side to a base 10. So the way we do that is we find what the, sorry, hang on a second. Okay, we're back. Sorry about that, a little interruption. So yeah, we need to get the powers, the bases to match here. So we take the logarithm of 17 to get the power of 10 that we need. And I'll just look at the book, and so basically 10 to the 1.23 is our left-hand side, and that's equal to 10 to the x plus 2. And now we can set the two exponents equal to each other, so we have x plus 2 is equal to 1.23, and x is equal to minus, what is it,
minus
0.77? Okay. So our answer here is x is minus 0.77, and if you plug that back in here, you'll get the 1.23 from. So that's that. So next part of this is exponential functions. Do you have the paper down like this? Okay, so I'm actually going to show the main format of the exponential equation, and then we'll talk about what the different parts are. So a of t is equal to a of 0 e to the k t. So the different parts of it, t is actually represents time, and k is a constant, e is the, is e?
It's e.
It's e, exactly. And a of 0 can actually be kind of thought of as like a y-intercept. So if we look at the graph of this function, it might look something like this. And a of 0 is actually represents the value when the time is 0. So this is time. As time increases this way, we have, this is where t equals 0 at the very beginning, the origin. And so the value of a of 0 is actually going to be could be thought of as the y-intercept. And then the values of y, it depends on what you're graphing. You might be graphing, can you think of any examples, Jimmy?
The division of bacteria?
Yeah, there you go. Like bacteria, growth of bacteria, voltage on a capacitor. They give some examples in the book. Money, so financial, growth of your portfolio or whatever. So, so this is the units of y might vary, but t is the value of the x is going to be time in this case. So, so we might have something like it might intersect the y-axis at 100. So at t equals 0, y is 100, and so y, that's actually going to be our a of 0. So in this particular example, you might have something like a of t is equal to 100, because that's our a of 0 value. E, and then maybe the k is some constant like 1.2 t. So you might have an example equation that looks something like this. So if k is a positive number, you're going to have a sloping upward. And if k is a negative number, which way is it going to be sloping?
Downward.
Downward, right? So you're going to have something like this. Yeah, let me draw the arrow, but and then of course if k is a larger number, it's going to grow quicker, and so you'll have something that looks something like that if it's larger. Okay, so let's look at an example. And example I want to do here. Actually, I didn't do it again. Okay, so let's I didn't go over one of the examples there, so let's go ahead and jump on to the last part of this lesson, which is compound interest. So compound interest we might have something like starting out with a principal of, let's say, $100, and it might compound annually, which means that the interest is calculated each year, or it might compound continuously, and so there's different equations for that. So if we look at just the simple example of, let's say you have an 8% interest rate and your starting amount is $100, this is considered your principal, and this is your rate. And the way you calculate this is you would say 100 times 1 plus the rate, and you actually convert this percentage into a decimal, so it would be 0.08. This equates to 100 times 1.08. And this would be for the first year. This is how much you would have, which ends up being $108. So then as you continue on, you would take this amount, 108, and you say 108 times 1.08, and that would be your second year. And if you continue that on, you basically have 108 is multiplied times the previous value times the previous value. And so you come up with an equation which is your total amount of n is equal to 100, or actually I'm going to say, I'm going to make it more general, is your principal times your rate plus 1, and this is to the n power. So total amount is to start with your principal, add your rate plus 1, and raise it to the power of n. This would be if it's compounded, and n is going to be how it's compounded. So if it's compounded annually, n would be the number of years. If it's compounded monthly, then n would be the number of months, and so on. So now, the other way to compound interest is continuously, and for that use a different equation. Do I have that one?
Yeah.
And it looks similar to what we had in the previous section of this lesson. And that is a to the t. So again, this is a of t is equal to a principal times e raised to the rate times time. And so again, as time increases, basically your rate is 8% or whatever, you use like 0.08, and raise e to that power. So let's go ahead and jump into example. Did I list what example?
15.
I guess it's only on one minute. Okay. So it says Roger deposited $5,000 in an interest-bearing account that paid 7.5% interest, compounded continuously. How much money did he have in 10 years? So we have a to the t. His principal was $5,000, and the interest rate was 7.5%. So we have 0.075, and then we have t. And how much money did he have in 10 years? So what we want to do is we go ahead and say A of 10 is equal to 5,000 E times 0.075 times 10 years. And so we plug all this into a calculator. I skip forward here. And we get A of 10 is equal to $10,600. So that's not bad. He over doubled his money in 10 years. That's probably, I don't know if that's typical or not. Okay, so that's lesson 115, and we'll go ahead and stop it there.